All right, howdy folks, happy Monday. Welcome back to geometry. Today is day 2 of unit 11, right? That means that we are diving headfirst into volume. On Friday, we covered the basics of volume in three-dimensional figures. Today, we're actually putting formulas to use, all right? Now, on that topic, we're talking about formulas. I do need to make an announcement up front. Make sure that you are using and annotating the new unit 11 formula sheet. Please, people, please use the formula sheet, right? Reason being, one, there are new volume formulas that are being added on in this update. So you're getting those in addition to the old area formulas, right? If you're just using the old one, you're only gonna have the area formulas. We've got like 3 or 4 new volume formulas that we're gonna use. So make sure that you have those volume formulas in your updated formula sheet, right? You can find that in Canvas. The other reason that I am really emphasizing, again, make sure you are using the formula sheet is because there were still people on the Unit 10 summative that didn't use their formula sheet, and it blows my mind, right? We're giving you this resource. Use it, please. All right, there's no reason to be writing down an incorrect formula. All right, make sure that you are using the formula sheet. All right, but with that, let's get into it. We got just some basics that we need to get out of the way before we start doing things with formulas. All right, so we've got this term here, a right prism. Right, a right prism is a three-dimensional figure in which the lateral faces are perpendicular to the bases, and in which the bases are parallel. Right, now what does that mean? Let's just talk about it with an example. So here we have a triangular prism, right? And this is actually going to highlight some naming conventions that you should know, right? When we talk about prisms, we usually have an adjective on the front. So we might have a triangular prism or a rectangular prism or a hexagonal prism, right? That adjective is actually telling us what the shape of the base is, right? So in this case, the base is not what we think of the bottom, quote, 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 right? It's not the bottom. It's not the thing that sits on the table if you were to put this prism down on the surface, right? The base is actually whatever that name told us it was. So we said that we had a triangular prism. That means that our triangles are the bases, right? And as per our definition, these triangles are parallel. All right. Now the faces that are not bases are called the lateral faces. So we've got this rectangle here is a lateral face. This rectangle here is a lateral face. And this rectangle over here is a lateral face. And these lateral faces are perpendicular to our bases. Right, now previously, we had only talked about lines and segments being parallel or perpendicular, right? So what does it mean for a surface to be parallel, right? Because previously we had just dealt with lines. So in order to illustrate this, just get a sheet of paper, right? Pick one that's not important. We're gonna do something with it in a sec, but just any sheet of paper will do, right? Take that sheet of paper, and I'm assuming you're sitting at your desk or your bed or your kitchen table or whatever, right? But hold that sheet of paper just flat, but above that surface, right? Above your desk or your table or whatever, right? So hopefully you're not holding the paper so it's tilting down or tilting up or any sort of which way. Hopefully you know what flat is, right? But that surface, your desk or your table, if let's say like this here, right, and your piece of paper, those two things are going to be parallel if both of them are quote unquote flat, right? If we extend them in any direction and they're not going to intersect with each other, right? So that's how we're getting to parallel surfaces or parallel planes. Right, what about perpendicular? Because previously we had only talked about lines and segments being perpendicular. How do we have a perpendicular surface, right? So in order to illustrate that, go ahead and take that sheet of paper and just fold it in half. It doesn't need to be a nice fold, doesn't need to be a perfect line at the corners type of fold, just fold it in half, right? But make a nice crease on it. And then, right, so let's get our piece of paper not so that it's still like folded all the way down or not open up all the way, but if you have got your desk here, get one side flush with the desk and get the other side of the paper going straight up out of the desk. Right, so this L shape, these perpendicular segments are kind of like a cross section of what you're seeing, because hopefully you're seeing something like this, right, with your piece of paper folded in half. So you can see that we've got a plane going straight up here and a plane that's flush on the desk here, right? Those two planes, those two surfaces are perpendicular. Right, so we're expanding our vocabulary and our concept of parallel and perpendicular here. So it doesn't just mean segments and lines, now it also means surfaces. All right, let's talk a little bit more about it. So we said that the prisms are named after the shapes of their bases. So triangular prism, hexagonal prism, right? But we also have a special type of prism. It's a circular prism, but we never refer to it that way. We call it a cylinder, right? So I'm sure you know what a cylinder looks like, but a cylinder is essentially a prism. It just has a circle for a base. Right, and here is one of those area formulas that I told you is on the formula sheet, so make sure that you're using the formula sheet. But just for the sake of summarizing it here, this is the formula that we will be using all throughout today. Volume is equal to the area of the base times the height. All right, let's get into it. Let's do some math. Let's start off on example 1. We're going to find the volume of this cheesecake looking dude. All right, determine the volume of the triangular prism shown below. All right, now hopefully you also remember from Friday that we said that the bases of prisms are congruent, right? We're saying now that they're parallel, they're also congruent, and that's just sort of a result of what's happening with those perpendicular lateral faces. It's kind of just like lifting, say, this triangle off the bottom and just gets lifted right up, sort of like an elevator. And so these two triangles here and here, those triangles are congruent, right? The congruency of those triangles is actually really important, because if we need to find the area of those bases, if we treated them both individually, we would actually only have one side length of each triangle and no angle measures. So if we didn't have any other lengths, it would actually be impossible for us to calculate the area of that triangular base. Right, so the fact that we know that these triangles are congruent, we know that this edge and this edge are congruent. Right, that's useful because now we can say that this edge is 10. And oh, look at that, right? Now we have a right triangle, right? Keep the right angle in the corner. We've got a right triangle with two sides, and that sets us up perfectly to get the other side. Right? Before we get there, though, I do want to point out one thing. I saw some people who are still doing this, and I do want to address it. Don't fall into the trap that people fall into, where they see the word base and they just assume base means bottom. Right? That is not true. The quote-unquote bottom is not always or not necessarily the base. Right? So if you are looking at this triangle and saying, oh, well, surely I must draw in this altitude, and then find this to be my height so I can multiply it by my base 26, right? That's not the way that you need to be going about this, especially because it is impossible for you to find that triangle without doing like 3 steps of trigonometry, right? It's kind of insane, like the amount of work that would go into this, when especially there's a better way to go about it that isn't gonna use any trig at all. It's actually just gonna take like 2 steps, 1 step, half step, I don't know, right? But really what we're going for here is these two perpendicular segments. Right? If you've got perpendicular segments in a triangle, those function perfectly for our base and our height. So we've got one dimension here of 10, and we just need to get the length of this leg here. Right? And the fact that we have a 10 and a 26 sets us up to do that. Now, I am going to tell you, I'm not going to do Pythagorean theorem. Right? I'm not writing out that whole thing. I am not doing all that work because I see a pattern, and it's a useful pattern. It's a pattern that I know, and it's a pattern that I appreciate knowing. I've got a 10 and a 26, and both of those will divide by 2. And if I were to do that, that would give me 5 and 13. And I know my triples. I know that third side is a multiple of 12. So accounting for the scale factor of 2, we know that our missing side is 24. Shablam. Right? And now I can calculate the area of this triangular base with one of my area formulas. Right? I know that area of a triangle is equal to base times height over 2. And again, I'm going to reiterate that we are talking about area at this moment. It is a 2D thing. So this height is the height of just this triangle, even though the triangular prism also has its own height of 7. So if you need to differentiate between like, oh, base meant something in unit 10, but now it means something different in unit 11, and height meant something in unit 10, and now something different in unit 11, if you need to, just differentiate them, right? You can make this like capital if you want to. You could say like B2 and H2 for the 2D figure, right? And if that's an issue, like totally fine, just make notes on how you're going to be approaching these formulas, right? But for the area of the triangle, we said that one dimension was 10 and the other was 24, and that all got divided by 2. All right, so that's the area of our base that we're going to use in our volume formula. Let's recall that the volume is the area of the base times the height of the prism. All right, and actually I'll just amend this and add a little b here, so area of base. Now here's what you're going to see me do. I actually am going to substitute in this fraction for the area of the base, right? Now, you know that I always tell you, hold on to those tangents and those roots and those whatevers for as long as you can. Don't touch the calculator till the end, because you want to avoid a rounding error. Now, if you're looking at this fraction and thinking, well, that's not going to give me a rounding error, those all divide nicely. Yeah, that's right, that's true, right? So we actually could divide this now and it wouldn't give us a rounding error, but there are going to be problems moving forward in the future where if you pick up that calculator and you round it too early in the area, it is going to throw your volume off, right? So just to avoid that, let's stay in the habit of whatever area we got. If we're not ready to write something on the answer blank, just hold on to it and don't touch the calculator, right? The calculator can handle a lot of stuff all in one line, so we're going to let it do its job. So I've got my area of the base here, and then in our diagram up above, we said that the height of the prism was 7, so I can just drop out that h and pop in the 7, right? And now this entire thing is my volume, and I can go ahead and enter that into the calculator, all in one line. You guys know that I'm gonna enjoy it because I get to do a fancy fraction. All right, 840 is the total volume. Right, and now's the time that we are going to go back and check for units. Oh, peep this. We didn't write down an actual unit on the diagram, but we are not done. We cannot just write 840 and walk away, right? Remember that if you are not given a specific unit, then you just use the non-specified generic units, right? We didn't have centimeters or inches or whatnot. So because we can't write down a specific unit, we're just going to write units. Right, only edit that we need to make here is we're going to make these cubic units because we were talking about volume, right? So when we were talking about lengths, they were just centimeters, right? We were talking about area, 2 dimensions. We were talking about square centimeters. Now we're in 3D, so now we're talking about cubic centimeters or cubic units in this particular case, right? 840 cubic units. So if you need a moment to pause the video and soak up example 1, now's the time. Otherwise, let's push forward to example 2. All right, determine the volume of a rectangular prism with a length of 11 feet, a width of 8 feet, and a height of 2 feet. Now, if you want to try this one on your own for a moment, go ahead and pause the video now. Right, otherwise, I'm about to push forward right now because I'm assuming that you had your chance to pause it. So let's go ahead and see how this one is done. All right, so you've got a rectangular prism with a length of 11 feet and a width of 8 feet and a height of 2 feet. And now I'm just going to do some notability magic and make this look like an actual rectangular prism. Boop, boop. Sublime. Oh, you just missed it on the dismount. I hate to see it. All right, there we go. So we've got a length of 11 feet, width of 8 feet, height of 2 feet. All right, and let's remember that our volume formula requires the area of the base times the height of the prism. Right, so really, and this is the interesting thing about rectangular prisms, is there are actually a whole bunch of different candidates for what the base could be. Any of the 6 sides of a rectangular prism can be considered a base. Right? Reason being is we said that the naming convention tells us what the shape of the base needs to be. So if we're talking about a rectangular prism, then we just need a pair of parallel rectangles to be our bases. Well, notice that we've got a rectangle here, and we have a rectangle here, and we have a rectangle here, which means that on the opposite side, so on the bottom, right, or on this side over here, or on that side in the back, right, all of those are going to be rectangles. So we kind of just need to pick 2 dimensions that we like to get a base, and then we'll multiply by our 3rd dimension, and that will account for our height or our lateral edge. Right, in this particular case, though, I'm just going to keep it simple. And so we will use this top face as our base, and then this 2 feet can be our height. Right, recall that we've got congruent edges here. So we know that this edge is 8 and this edge is also 11. So for the area of the base, 8 times 11, 88, times the height of the prism, which is 2, volume is equal to 176. Quick maths. And then the unit we were given was feet, but we were talking about volume, so cubic feet. All right, so if you want to take a minute to soak up examples 1 and 2, pause the video now. All right, and otherwise, unless you want to play it back and see part of that again, let's push forward to example 3. All right, determine the volume of the isosceles trapezoidal prism shown below. Now, here's what we're going to do. The first thing that I need you to do, and I'm going to give you a second to do it, but I want you to highlight what you think the base of this prism is. Right, highlight the base of this prism. All right, are you good to go? Have you highlighted it? Have you picked one of those 6 faces as your base? All right, let's check it. Now I'm going to tell you there's 6 options that you could have picked here. One of them is definitely not the base. All right, and it, again, is a common trap that people fall into, right? Because they're not minding the gap, so to speak. But you do need to be aware of it. If you picked this quote unquote bottom side, quote, 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 of the prism, this face on, again, quote, the bottom is not the base, NOT not. All right, so the same way that in our triangle, right, let's refer back to this right triangle over here, we said that we didn't need to be treating 26 as the base, right? So don't fall into that trap of whatever's on the bottom is the base. Similarly, in this trapezoid, it's not even that we don't need to pick this face here as our base, it's that we can't be picking that face as the base, right? Just because it's on the bottom, just because if you were to take that shape and place it on the table, that's what would make contact with the surface, right? Just because that's true doesn't mean that it's the base of our prism. Recall again that we have naming conventions for these prisms as to what our base is, right? We said that whatever adjective, whatever shape we use to describe the prism, that's telling us what the shape of our base needs to be. So the fact that we have a trapezoidal prism means that our bases need to be trapezoids, right? So this is the surface that is sitting on the table, this blue one, but it is not our base. In order to get our base, we are going to, come on now, we are going to pick one of our trapezoids, right? And you do have options. You could pick this trapezoid here, you could pick this trapezoid back there, kind of your call. Again, they're congruent, so it doesn't really matter in terms of finding area. Right? But we do need to find the area of this trapezoid so that we can do area of base times height. So let's recall off of our formula sheet that the area of the base, which in this case is a trapezoid, so the area of a trapezoid is equal to base 1 plus base 2 times height over 2. Right, again, you might not recall the area of a trapezoid, right? You might not know that formula dead cold off the bat. Use your formula sheet. Refer to the formula sheet. Right, but that's our formula. So we need to know the lengths of two bases, and we need to know the height. Right? Super nice, because we have one base here, that's 12. We have our height here, that's 8. So we just need to find the length of this base right down here. Right, and there are a couple ways that we can go about it. So we know that this trapezoid is isosceles. It's something that was told us in the prompt. So we know that these two segments both have a length of 10 centimeters. Right? And we can also draw in an altitude here, the same as we did in Unit 10. Right, and now we've got some options. So 12 centimeters. All right. And really, for us, if we have this piece of the base, we need to be finding these two pieces so we can add them together and get the entire thing. All right. Now, again, like I said, you've got options. You can do Pythagorean theorem. I'm not going to do Pythagorean theorem, but you can. But notice that you've got an 8 and a 10, right? 8 and 10 should be, you know, big flashing red light at you, like, hey, 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 triples, right? So we've got an 8 and a 10, and that aligns with our 4 and 5, which means that our missing side is a multiple of 3, and it's by a factor of 2. So this segment down here is 6 centimeters. Right? And because these triangles are congruent, because this height is still 8, we know that this is also 6 centimeters. So altogether, we've got 6 plus 12 plus 6 is 24. Quick maths. Right, so now if I'm going to solve using my area formula, now the area of the trapezoid is the first base, which is 12, plus the second base, 24, times the height of the trapezoid, which was 8. Remember, we're just solving for area of a trapezoid at this moment, and that gets divided by 2. And now I can go into volume mode. So volume is equal to the area of the base times the height of the prism, right? Which again, let's recall, height in this sense means the lateral edge. So even though if this trapezoidal prism was sitting on a table, it would still be 8 centimeters tall, right? Like it would be 8 centimeters off the table, this face. The height is referring to the length of the segment that is perpendicular to the base. So we want a segment that is perpendicular to this trapezoidal face, and that is going to be these 4 segments here. Right? Actually, this 10 is kind of misleading. I'm going to drop that right over here. Right? But we know that one of those perpendicular segments is 20, which means that they're all 20 centimeters. So the height of our prism, the value that we're going to sub in for h here is going to be 20 for those 20 centimeters. All right? So area of the base, I will just duplicate this, because that's what we said the area of the base was. And we just said that the height of our prism was 20. And so now I can plug that entire thing into the calculator. Right? And again, you know, I enjoy it. Fancy fraction. Right? But I also enjoy quick maths. So I can do 36 times 4 times 20, which is the same as what we wrote. Quick maths. And that's 2880. Now let's check our units. We were given centimeters. We're talking volume. Cubic centimeters. All right, so if you need a minute to pause the video to soak up example 3, do so now. All right, otherwise, this kind of closes out our recorded notes for today. Everything else that you've got in this PDF are practice problems that you're going to be entering into Go Formative. So thanks for hanging out and doing some math with me. I will see you on the Zoom call for us to work on that Go Formative.